Chapter 6.6, Trigonometric Form of a Complex Number. We'll write trig forms of complex numbers and multiply and divide complex numbers written in trigonometric form. So trigonometric form of a complex number. So what is that? So the trig form of the complex number z equals a plus bi is z equals r cosine theta plus I sine of theta, and where a equals r cosine theta, right? So a here equals r cosine theta, and then our b equals r sine theta, or r equals the square root of a squared plus b squared, and tangent of theta, we remember, is b over a. The number r is the modulus of z, or just the absolute value of z. It's the distance to the origin, and theta is an argument of z. The trig form of a complex number is also called the polar form. There are infinitely many choices for theta, so the trig form of a complex number is not unique. Normally, theta is restricted to the interval between 0 and 2 pi, although on occasion it is convenient to use when theta is less than 0. So we're going to write the complex number z equals -2 minus 2 root 3i in trigonometric form. And so a couple things we need to remember. Number one, we're going to write it in this form. So z equals r times cosine theta plus I sine of theta. So what we need to know is r. So r equals the square root of a squared plus b squared. Then we need to know the angle, so tangent of theta is b over a. So we need to solve for these pieces. So let's solve for the modulus of z. We're trying to find r, so that's the square root of a, which is -2 squared plus -2 root 3 squared. So the modulus of z is just our radius. Okay, so that's what we're finding. So this is the square root of 4 plus 4 times 3. So that equals the square root of 4 plus 12, or the square root of 16, or our r equals 4. Then we need to find theta. So let's graph this first. -2 minus 2 root 3, that is left to down to -2 root 3, so we are here. And so we want to find theta. And to do that, we remember that tangent of theta equals b over a. So b is -2 root 3 over -2, or it is just positive square root of 3. Now, when does it equal square root of 3? So remember, that's root 3 over 2. In order to get that, it's negative root 3 over 2 over -1/2. So y is root 3 over 2. So that is going to be one of the pi over 3's. And so that'll be 4 pi over 3. So theta is 4 pi over 3. And so now we can write our trig form. So the trig form, again, is z equals r cosine theta plus I sine of theta. Let's replace everything that we know. The radius is 4, and then this is cosine of 4 pi over 3 plus I sine of 4 pi over 3. And so this is what we were looking for. So try the example, write the complex number z equals 6 minus 6i in trig form. So this is, you find the radius is 6 root 2, tangent of theta, or theta, is 7 pi over 4, and so you get 6 root 2 times cosine of 7 pi over 4 plus I sine of 7 pi over 4. Now let's write a complex number in standard form. So we're going to go back the other direction. So write z equals square root of 8 times cosine of -pi over 3 plus I -pi over 3 in standard form, a plus bi. So we need to identify what we can find here. So let's see, square root of 8. What is cosine of -pi over 3? So -pi over 3 is here, and so that is going to be x is 1/2, and y is root 3 over 2, negative root 3 over 2. So therefore, cosine of -pi over 3 is 1/2, and then minus a root 3 over 2i. So then we can simplify further. Root 8, that's really 2 root 2. And then let's 2 root 2 times a half minus root 3 over 2. So then this becomes root 2 minus root 6, and then I. So try this example here. Trying this out, you find that 2 pi over 3 is negative half and root 3 over 2, so you just substitute, and therefore you would get negative 4 plus 4 root 3i.